Hello everyone and welcome to this episode of Altitude. This is our monthly look at the world of aviation and air traffic control. Delighted to have you joining us today. I'm Fran Slater and I'm going to be your host for today, and we're going to be talking about the weather. The weather influences all our lives, doesn't it? Whether you just think about, oh, I wish I brought an umbrella with me, or I should have put a coat on, or oh, I should have put sun cream on the kids this morning. But for air traffic controllers, the weather can be a little bit of an obsession, a little bit more interesting than that. Whether it's rain, wind, snow, thunderstorms, all of those can conspire to make things more interesting for us, more complicated for us, and turn over some of our well-planned activities. It creates a more challenging environment for us, sometimes a more complicated one, but maintaining safety is always our first priority, so we have to get it right. But why does a storm that happens in Athens leave you grounded in Glasgow? What conditions do we worry about when we talk about the weather in air traffic? What do we need to do, and how do we find out about the weather? We work very closely with the UK Met Office, the airports and the airlines to try and minimise the disruption for everyone. So how do we do that? And that's what we're going to talk about today. And I'm really delighted there are no two better people to help me talk about that today and to answer those questions than the two guests we have with us. I've got a big welcome to Emma Corrigan, who is the Ops Manager and Meteorologist with the UK Met Office, and also my colleague Kevin Morgan, who manages Network Operations Delivery. So hello to both of you two.
Hi, afternoon.
Hi, nice to see you both. Emma, do you want to start by telling us a little bit about who you are and what you do?
Yeah, of course. Thank you so much for inviting me today. It's really exciting to be here. My name's Emma Corrigan. I've been in the UK Met Office since 2011. I started my career as a trainee forecaster, and since qualifying, I've spent a lot of my time focusing on the civil aviation industry, in particular specialising in our work on site with customers, for example, yourselves at NATS, but also at Gatwick Airport and at EasyJet as well. And yeah, since 2017, I've been at NATS Sonic, leading the team of meteorologists based there, and also managing the service we provide. That's making sure that we are bringing the latest research, innovation capabilities that the Met Office can bring into our service for not only NATS, but also wide reaching into the UK civil aviation industry.
Brilliant, thank you. And Kevin, tell us about you and what you do.
Hi Fran, thanks for having me. I'm really looking forward to today. My name's Kevin Morgan. I've been in NATS forever. I've done 32 years this year. I'm an air traffic controller by background, but my current role is to manage the network ops delivery. That function is a brilliant team based across both our Swanwick and Prestwick centres, and we're looking after the kind of operational demand and capacity balancing that we do through the London flow management position. My team work H24, 365 days a year, and I work very, very closely with Emma and her team, as I do with you, Fran, and your team. And it might be known that I'm a little bit of a weather geek on the side as well, so I'm sure I get on Emma's nerves and her team as well. But delighted to be here today to talk about the weather with you both.
Brilliant, thanks very much. And I'm Fran Slater. I've been a controller now for 23 years. I've been in NATS for 26 years, so not quite as long as Kev, but getting that way. I'm a controller and a supervisor. That means I spend some of the time with a headset on talking to planes and telling them what to do and where to go. And I also spend some of the time managing those positions, making sure we have the right numbers of planes and the right people to work them in the right places, managing the traffic flows and making sure we're doing everything we need to do safely. So that's a little bit about us and our jobs. Emma, tell me what's different about an aviation forecast to the normal forecast that the public gets.
Yeah, I guess for majority of people, they're more familiar with a public weather forecast, and in particular, a person standing in front of a screen, a map behind them, talking about sunny spells, scattered showers, quite general weather information. But for aviation, we need to go into a bit more detail at times, particularly certain weather criteria. So for wind, we talk about wind in knots rather than miles per hour. We also give more detail on the direction of the wind. That can have a really big important impact on whether or not planes are able to land. If it's along the runway, then that's usually fine. But if it's at 90 degrees to the direction of the runway, that can have a problem, particularly if it's a stormy, very, very strong wind event. As well, we give information on cloud, particularly how low it's going to be. Whereas for the general public, it's cloudy or it's not cloudy, but for aviation you need to know how low that cloud is, and maybe as well what type of cloud it is, because there's thunderstorm clouds which have hazards associated with them, including turbulence and icing, which can impact the efficiency and the ability to aircraft to handle those conditions as well.
Yeah, and I remember what it was like in the days before we had you there. Kevin, tell me what you think it's like having the Met Office in with us now, and how things worked beforehand.
Yeah, well, it's been absolutely transformational for us getting the Met Office on site. Well, we've always had a strong relationship with the Met Office, but previously the forecasters were based on the aviation desk in Exeter at the Met Office there in their ops centre. And the problem that we had was that, quite understandably, they didn't understand the way our airspace was constructed and our procedures and how things worked. What bringing them on site has done is it meant that they now understand how we work. So they understand our traffic flows, they understand, the way we staff the ops room, they understand the things that cause us and our customers issues. So we're able to communicate, much more effectively. I know that there's been a lot of discussion around data. Do we need more data on the weather? Do we want to exchange data with the Met Office? And actually, the beauty of having the forecasters on site is they're experts at interpreting that data, and now they can speak a little bit of air traffic, and your team and my team now can speak a little bit of Met Office. We've got that wonderful collaboration with them, and I think, one of the things that's really important for us in aviation and in NATS is that consistency. We can all look at 1,000,001 apps, and if you look at enough apps, you'll find the weather you actually want, but whether it's the actual weather you're actually going to get is different. So we've got that fantastic relationship with the UK Met Office, where they give us a consistent forecast, and they're able to kind of tune their forecasts into what we actually need to see to run the operation, and most importantly safely, but also efficiently.
Yeah, because we want to do our best all the time, don't we, to let everybody go where they want to do, with no delays, getting where they want to get to, doing everything they can do. But, sometimes the weather hampers us in what we do, doesn't it? So that's that. So let's talk a little bit about what we mean with particularly severe weather from an ATC point of view, from an air traffic control point of view. What do we think the most difficult things are to deal with? From my personal point of view, I know it's thunderstorms. I hate thunderstorms. I don't care if the rain is here, that doesn't matter to me. If the thunderstorms are where my planes want to fly, that causes me a problem. So I want to know a little bit about where they're going to be, how they're going to move, what things are going to happen. So Emma, tell us what you know and what you think about when you think about severe weather and what you're going to be warning me of.
Yeah, I like to break the weather up into weather that impacts airports on the ground specifically, and then the weather that happens en route when a plane is, flying from A to B. So for airports, the severe weather is particularly snow, fog, strong winds. The direction of the wind as well is very important, particularly kind of crosswinds. And when we're talking about weather en route, where the plane is kind of cruising, it's thunderstorms, turbulence, potentially icing as well. And it all depends on the thresholds and how severe it is. Depends on the aircraft type, depends on the airport, lots of nuances. And, I think that's how the team based with NATS and your teams at Sonic understand and get to know those thresholds and those sensitivities.
Yeah, so let's talk a little bit about fog. Kevin, when we get fog forecast or when we get low cloud forecast, that's obviously going to be a bit of a problem for us. So what are your thoughts from a network management point of view when we know the weather is going to be foggy?
Yeah, fog is difficult, and I think I'd be fair in saying, Emma, that it can be quite difficult to forecast very accurately as well. And there's a lot of local effects around a particular airfield can influence where the fog is going to form or whether it's going to stay and that kind of stuff. The thing about fog is it can severely affect the arrival rate, the amount of aircraft that an airport can take at any one time. And for us, the priority really is to be able to plan the impact of how that's going to affect the airport, the airlines, and the travelling public as well. So some of our procedures that we have set up are based around these kind of thresholds that Emma spoke about, and with a certain forecast might lead us to take action ahead of the event, maybe even the day before the event. So if we know there was, severe fog forecast at an airfield, we might apply some measures to reduce the arrival into that airfield, ahead of the event. And what we've learned from speaking to our customers and the airports is that planning is really important. It's unforecast events that are really, really challenging for everybody. If we know something's coming, we can do something about it. And that's what we've learned with working with the Met Office, having them on site and say reaching out and speaking to our customers in a pre-tactical, so ahead of the event, is that pre-planning is extremely important. I think there's also some other stuff that which perhaps is not severe weather but can have a big impact on our operations. So one of the things that occurs in the summer can be runway temperature. So you might think in the UK it's generally a kind of a moderate climate, but those runway surface temperatures can get really, really hot, and that can have an impact on the operation as well. Also things like snow, not just an impact on the airfield itself, but also controllers getting into work and pilots getting, that impact on the ground of people getting in, things that perhaps people wouldn't generally think of as an issue. Also, I think certain countries have experience of very severe weather, so we tend to find that pilots that originate or fly a lot in the US, they're very sensitive to severe turbulence because they have some monstrous cumulonimbus clouds that go really high and it can be really bumpy, and they tend to get more concern around turbulence in UK and Europe, whereas perhaps European-based crews are not so anxious about it because the occurrence of severe turbulence is not as great over here. I mean, I've got a friend in kind of the Dallas area that's telling me about tornadoes and hailstones the size of golf balls and stuff that we generally don't have to deal with that. So the weather across the globe is very different, and that has an impact on us as well.
Absolutely. And I know we're going to get to some Q&A later on. Some people have sent in questions in advance, and you're welcome to ask questions through if you want to. They'll come through to us later on and we'll answer them. But I know one of the things that we were asked about was, why do we have to slow down the number of arrivals when it's foggy? And surely the planes can cope with it. And there are lots of different reasons why you might not be able to land as many aircraft at the same time when it is foggy. And that could be to do with the qualifications of the pilots, or it could be to do with the systems on the aircraft. But actually, it's a little bit like driving your car in fog, to steal someone else's analogy that I know from NATS, and he'll know when I say this. But it's a little bit like driving on the motorway in fog. If you drove on the motorway in fog at 70 miles an hour, your chances of hitting something are greater, and you can't see what's in front of you as much. On the airfield, on the ground, when the aircraft are moving around and going back to their parking spaces and taxiing to and from the runway, things just can't be seen as clearly, and the pilots will just need to go that little bit slower. And so we need to create probably bigger space between the arriving aircraft in order to make sure that they can land safely and vacate the runway and give enough space for the other departures and the other arrivals to happen. So lots of different things affect it, and we take all of those into account and then work out what a safe number of aircraft is to come in at that time to make sure that everything works. I want to pick up on something you said earlier, Emma. You were talking a little bit about winds and crosswinds, particularly. I know that for the non-aviation geeks out there, aircraft much prefer to land and take off into the direction of the wind. It helps with the lift. It helps to keep the aircraft flying nice and stably. And like Kevin was just saying, if you get a lot of turbulence, it's very uncomfortable for the passengers. The pilots are not feeling as comfortable either, and it's not a great place to be. So we try and avoid all those things as much. I guess the most recent example we had of sort of really windy conditions, stormy conditions, was probably when we had Storm Eunice earlier on this year. Emma and Kevin, were either of you on duty for that?
Thankfully, no. I wasn't. I was actually trying to have a weekend away in a shepherd's hut on the south coast, which I did delay by a day because it was not going to be that great. But I think Emma was around and could probably tell us a bit about how that forecast panned out.
Yeah, I was around in the lead up and also on the day itself. It was a very busy week for the Met Office and the weather forecasters, and also I guess a very busy time for controllers and supervisors based at NATS. It was a really interesting week. We had 2 named storms named on Monday, so several days in advance, giving good heads up notice to yourselves. So we had Dudley and Eunice named on the Monday, and ended up with Franklin again on the Sunday as well. So, you know, it was a very stormy week. Thinking about Eunice itself, it was coming through during the day, whereas Dudley was more of an evening overnight feature across the north. So you have a higher load of traffic during the day, so potentially more sensitivity as well. We saw widespread gusts of 50 to 60 knots. The direction wasn't great. It was just off a southerly, and there was wind shear at the surface as well. So very, very turbulent approaches observed and seen. Big Jet TV, isn't it?
Yeah, exactly. That is exactly what I was just going to say. So again, the majority of runways, not all of them, but the majority of runways in the UK are aligned sort of approximately east-west. Kev, would you agree with that? I think so. You know, we prefer mostly for the winds to be from a westerly preference or an easterly preference, and when they are more crosswind, that's much more awkward. We've actually got a video clip to just show and talk about, and perhaps Kev, you can help me talk about this as we watch it up for you, of the radar recordings of some of the things that happened on Storm Eunice Day. So let's see what happened on the day and what it looks like.
I think whilst we're looking at that, I think one thing that I find amazing, and as I say, being somebody that's got an interest in the weather anyway, is how well some of these models, the Met models, pick up these storms. You know, they're not in existence. They're not in existence for a few days, and yet the modelling was incredible. Yes, the track gets refined as you get closer and closer to the time of it happening. The other thing I think is really articulated well, because we had 3 named storms during that 1 week, is the naming of the storms actually helps with the communication, because you know the event you're talking about, you tie it up with that name. So I think that proved well.
And you can see on the radar recording, you see aircraft arriving into mainly Heathrow there, and sometimes they're not managing to get in and they're turning around and doing what's called a go around, which is, you know, as you've seen maybe on Big Jet TV, or when the plane can't actually safely put itself down on the ground or be put down by the pilots, and it's going around and coming around for another approach. And sometimes the aircraft are going around for another approach immediately, and sometimes they're going out to hold off for a little while. Maybe it's been very uncomfortable for the pilots. And, you know, we have to remember as well at the time of Eunice that quite a lot of pilots hadn't been flying because of COVID, so things were only just getting back to normal for them, and it was a bigger shock, I think, to them. And we were having to put in bigger space to give the aircraft a chance to try and get down on the ground and make sure that they could land safely and have plenty of room to roll out and reduce their speed if they needed to. And you can see the difficulties that causes. So Kevin, tell me, when we have aircraft going around and aircraft holding, how does that affect what we do with the numbers of aircraft?
Yeah, so I think that's a really good example to the question that was posed at the start around, you know, why if there's fog in Athens or is there a storm in Athens, do I get delayed departing from Glasgow? So if you imagine, you know, any airfield, in this instance we've got Heathrow, which, you know, could land 45 aircraft an hour in benign conditions. You've already got a factor of some weather impacting it, so we know they're not going to be able to land 45 an hour because they need to stabilise on the approach a bit more. They might need a bit of a longer track. So you imagine then you've reduced that by a figure, and then you've got aircraft going around. So they're now adding to the number of aircraft you've got to try and land, and they're going in the hold. You could see them on the visualization there, kind of in that racetrack pattern just to the southeast of Heathrow. So you're constantly adding to those numbers. So the best thing we can do, and this is what I was talking about earlier about the importance of planning, is that we can apply a measure across the whole of Europe that says, you know, at the moment we can't accept the normal number of flights into any particular airfield, so we have to reduce that rate. And so by communicating and applying that measure in advance, we can slow the number of aircraft down that arrive at the airport. Yes, it does mean some delays, and it is the last resort we use. We hate delaying flights, but it ensures there's a safe number of aircraft arriving into an airfield. The other thing it does is it tries to reduce the amount of airborne holding that we do. Airborne holding, as you'll know, Fran, is quite workload intensive to manage. And obviously has an environmental impact, which we try to minimise as well. Yeah. And the trouble is with a big storm like Eunice and others we've had go through is that they're not just affecting one airfield. It's not, sometimes you get like a thunderstorm that sits right over the top of an airfield, and it can be just that airfield that's really affected. Eunice was widespread, particularly along the south, so a lot of your airfields are impacted. And if you just imagine the kind of workload multiplier in then all of those airports affected and all those flights going around, and and sometimes have to divert elsewhere, we have to really control the flow of traffic into the UK, which is what my team do on a daily basis to make sure that we can all cope with the amount of traffic that there is in the skies.
Exactly, and then we as controllers will be looking after those aircraft when they're there, and then we're able to cope with, so when they do need to go around and come back and have a break or try again for the approach, we can fit them into the sequence. And if aircraft are struggling to land, they can talk to us about what other airfields they can go to, where they might be able to divert to make sure that they can land safely. All the time what we're trying to do is keep the operation safe and keep everyone moving the way they want to go, and just make sure we can do as much as we can for everybody from that point of view. So safety is always our top priority, but like you say, Kev, we also want to reduce delays. We don't like nobody wants to be held on the ground, nobody wants to be having delays in the air, and we're trying really hard as a company now, especially to avoid the environmental impact wherever we can. We need to try and reduce the amount of CO2 out there, and anything we can do to help that, I think, is really, really important. Emma, tell us a bit more about then how long you would be able to give us in advance about forecasting storms. I know with Eunice you had quite a long time, but that can vary, can't it?
Yeah, it all depends on the certainty in the forecast, and there's various ways that us as forecasters and the Met Office work to quantify certainty. We use various different types of model output. Any kind of small differences at the beginning of a forecast and how much observation data we can bring in will greatly impact or make better the output of the model. So there are some situations where there's a lot of uncertainty in the initial starting conditions of the forecast model, which then spread over time will just grow even larger. So with Storm Eunice and Dudley, we had several days advance notice, but with Franklin wasn't named until the Sunday. So it just shows the difference between just 1 week, the difference in certainty, and therefore the ability to put that communication out there in terms of a potential storm and a potential disruption.
And Emma, I think another difference that's highlighted another difference between perhaps the general public type forecast and aviation is we tend to use probabilities in the aviation domain. So you'll give us a forecast of the probability of an event, whether it be fog or whatever that is, and then we take action based on the severity or the likelihood of that occurring, which is quite different from the way that the public forecast might work. And some of our procedures are already pre-agreed. So if there's a very high probability of an fog event at an airfield, we might take action the day before, as I said, because a planned operation is safer, it's more stable, it's more it's just easier for everybody to manage.
Yeah, but not every storm gets named, Emma. So why do we name storms, just quickly?
So the storm naming convention came in about 2015, and it's really to more so people can be aware that this is different from your normal everyday weather. It's usually when we have an amber or on the rare occasion a red national severe weather warning in place. So it's reached the level where there's going to be impact and people need to be aware. So it's to improve awareness and to minimise potential disruption or impacts that people will see in day-to-day lives when they're out and about.
Yeah.
Am I right in saying that the Met Office is a joint thing with the Republic of Ireland, and they're alternate between kind of Irish names and the UK names? Is that correct?
Yeah, the kind of structure of it is kind of based off what the US started doing with the tropical cyclones. We've kind of taken that as a kind of a good structure and alternate between male female names, and also we work with Met Éireann and also KNMI, which is the Dutch Met service provider, and together the general public can put in their name requests. And I don't know how it's done, but names get picked each season and different names are used each time.
I'm not sure I've seen a storm, Kevin, but I don't think what that would be like. I think that's a good point you make there, Em, about obviously the weather is not isolation in the UK, and we do work quite closely with our European European air traffic kind of providers, as well as other European weather agencies, particularly in the summer. You know, the biggest risk for us in the summer is Fran's favourite sort of weather, as she's already described, thunderstorms. So you get these kind of strong convective situations which can cause an awful lot of disruption for aviation. And over the past few years, we've been involved with cross-border weather, which is kind of coordinated through Eurocontrol and different Met agencies across Europe, because clearly the weather doesn't stop at our UK geographical boundary. It's spread across it, and that, again, that coordinated approach across Europe gives massive benefits to the way we can kind of run the service and manage the service.
Yeah, I particularly like I don't like thunderstorms at all. I hate thunderstorms because they're very annoying. But what I like about having the Met Office with us now is that when you tell us about thunderstorms, you start to tell us where they're going to go, how quickly they're going to go there, so we can start to plan a little bit around our routes. One of the reasons I hate thunderstorms so much is it just has a sort of funneling effect on my traffic. No, generally aircraft don't want to fly through thunderstorms, because I'm sure you'll talk more than I could, Emma, about it, but the thunderstorms will generally have sort of strong winds in them. They might have, you know, various bits of precipitation in them that could damage their aircraft, make it very uncomfortable to fly through, and so they want to go around the thunderstorms as much as possible. And so unfortunately, if everybody tries to get around the thunderstorms, they all want to go into the same piece of airspace, which can make it a little bit more complicated. It's a little bit like when you're driving on the motorway. I'm going back to my car driving again, but you know, if you're driving on the motorway and there's 4 lanes and suddenly they have to close 3 lanes and everybody has to funnel into one, you get that big tailback and that big queue of everybody trying to fit through. And we're not in a position where we can fit all of those aircraft into that space at the same time. And if you imagine then the 3D version of that with layers of levels above it and layers of level above it and above it, that we've got to try and make sure that that happens so that it is safe. So, you know, what thunderstorm information can you give me, Emma?
I think it depends on the situation. If it's a kind of a band of heavy showers with thunderstorms in it, they generally are quite, I wouldn't say easy to track, but generally something that we can track more easily. Whereas if it's pop-up showers that develop through the day, then that could be more difficult. I use the analogy of like when you're boiling a pan of hot water, and when it starts boiling, you see the bubbles come up. You have no idea where those bubbles are going to be sometimes. It's a similar sort of things for thunderstorms. If you've got a nice hot summer day and you just see some showers starting to develop, it's kind of a very similar thing where you know it's going to get hot and warm and you know there's going to be showers develop. You just sometimes don't know exactly where those showers are going to be.
Yeah, absolutely. Yeah, but I think the really great thing is that when you see those develop, you give us an idea of the trajectories, the lines they're likely to take and how quickly you think they're likely to move, and you keep that refreshed for us. And from a supervisory point of view, when I'm trying to manage the sectors and make sure that nobody's getting overloaded, I need to make sure that we can keep those sectors safe. Knowing where that weather's going to be and how long it's going to be there for can make a significant difference, which is why sometimes we can let some routes flow quite freely, but sometimes we need to restrict others. Is that what you would say, Kev?
Yeah, I would, and I think something that might be interesting to people that kind of just got a passing interest in this, rather than us that are kind of bread and butter every day, is that, you know, generally when the airspace is busy and we've got more and more flights in it, what we like to do is we like to split the sectors up into smaller and smaller bits of airspace and put more and more controllers in them. We kind of split those sectors out because that enables us to manage more flights. It doesn't work like that with weather, because very often when you've got a big chunk of weather in your sector, you've got aircraft going all around it, avoiding it, and very often they can stray quite a long way off their track. So sometimes it's a bit counterintuitive, but sometimes you actually combine sectors and chunks of airspace together, because if you tried to keep them separately, the coordination between the different controllers in different pieces of airspace would be the constraining factor with workload. So weather is quite different in terms of the management of airspace and demand than other constraints that we have.
Yeah. Emma, are things getting worse? Are we going to see more storms like Eunice and things like that with climate change? What's going to be different in the future, and how does the Met Office prepare for that?
Yeah, so the Met Office not only does a lot of weather forecasting, there's also climate research that the Met Office gets involved with. We have a big centre called the Hadley Centre with lots of climate researchers specifically looking at climate change and what that may mean for industry like aviation. And last year we worked alongside a company called Aegis, and also that was on behalf of Eurocontrol to look at what potentially could we see in the future, and therefore how can the industry mitigate against that, or make sure that's included in their resilience plans. A couple of things were found in that report. Some I suppose more negative, some potentially more positive. So across Europe there'll be more airports at risk of flooding due to storm surges and sea level rise, particularly the more local, the smaller airports, and that's obviously potentially going to impact tourism as well as day-to-day activities. There's also an aspect of storms becoming more frequent and more severe, particularly across Northern Europe, less so across Southern Europe, which is going to potentially increase the weather delays and also distance that aircraft have to travel around those storms to avoid those hazards associated with thunderstorms. A few more positive things, I guess the changes in the jet stream would mean that transatlantic flights will reduce in duration. Not huge amounts, but it's still slightly quicker, so using less fuel. And finally, with the kind of general warming climate, the people are more likely to potentially use the shoulder months either side of the peak summer as the opportunity to use those times to go on holiday and travel. So we may see an expanded summer season as well.
Okay, so it's going to get more and more interesting.
Mm-hmm.
We've got a question that's come in saying that weather and aviation obviously know no boundaries. That's a good thing. I like that. What activities are NATS and the Met Office undertaking to support coordination with counterparts in Europe? Kev, maybe you could talk about what we do with our European counterparts from an air traffic point of view.
Yeah, sure. Great question. That I mentioned earlier that we get involved in the summer around the convective season around sharing not only the forecast data but the impact of that with our European colleagues, but also weather resilience. So being resilient to these weather events is a key thing, and NATS and the Met Office, we participated in a weather resilience conference with Eurocontrol a while ago, and we were able to share some of the techniques and best practice we use in our part of the European network for managing some of these events. And I'm really pleased to say that some of the things that we presented and the way we use are now being rolled out in other airfields across Europe. So we're kind of recognised as being kind of pioneers in some of the techniques and tools that we use. And it's only by bringing the Met Office really becoming part of our team. I mean, I guess I didn't mention that earlier on, is that yes, Emma and her team are based at Swanwick, but and yes, they're employed by the Met Office, but as you know, Fran, they're actually part of our team. We really think of them, and that's where the real benefit comes. So some of the tools and techniques that we use, particularly around low visibility and forecast fog, means that the impact to our customers is less than it would be if we just use standard techniques. So as well as so sharing this information, it's also sharing the tools and techniques and best practice that we've developed, so other people can benefit from them too.
Yeah, and that's really important. Emma, is there anything you want to add to that?
No, I just think it's great that we're able to collaborate with our Met providers across Europe to help support a wider reaching audience, and making sure thunderstorms don't stop at boundaries of countries, so we need to get that joined up forecast and story there. So I think so
we can all help each other. That's the best way.
Sometimes I wish they did. When I see them coming up over the French coast, I wish they did just bounce off the kind of UK airspace boundary, but sadly they don't.
No, unfortunately not. So we talked a bit about what we would call sort of normal weather and severe weather for us. What about space weather? I'm not very clued up on space weather, but I know that Kev is, and I'm sure that Emma is. So tell me a little bit about space weather. Emma, tell me a bit first.
Yeah, so this is quite a a new area, I suppose, of weather when it comes to thinking about it in the industry and also in people's operations. There's been a real push, I suppose, in the last five years in particular, to make sure that people are aware of it and people know what to do when there is space weather. So the sun follows a kind of a 10-11 year cycle. We're just coming out of a solar minimum, so activity on the sun has been lower. And when we talk about activity on the sun, we're talking about solar flares, geomagnetic storms that emit radiation and high energy particles out into the solar system, and it arrives on Earth and impacts the ionosphere, and therefore a lot of the technology we have can be impacted by it. And now going forwards into the mid-2020s, we're going towards more of a solar maximum, so we're more likely to see solar flares and more likely to see more severe, I guess, events across the surface of the sun, and therefore the higher risk of seeing impacts on Earth.
So, Kev, what does that actually do for us? What problems does that cause us then?
What does it do for me? It really reaches at my inner geek. I love all this kind of stuff. It's great. So aviation has become more aware of some of the impacts of space weather, and many people will be asking, what is this space weather? And there's some really good, Met Office have got some really good resources on their website which give you an overview. There's also a really good podcast in our time on the BBC Sounds. There's a really good episode on that, on space weather, that's worth a listen for anybody that's interested. And airlines are becoming more aware of some of these impacts. So, we use a lot of space-based technology, GPS, that kind of thing, and satellites can be impacted by space weather. Power grids can be impacted by space weather, and it's about building more resilience to these events. So the Met Office have got a space weather centre which is based at Exeter, and they work closely with their colleagues in Colorado in the US to do space weather forecasts. And I guess the most kind of obvious thing that space weather does to the public is what causes the aurora. So you often see lots of wonderful shots of aurora borealis when that's visible, sometimes from the north of the UK, and that's kind of the most obvious effect. But it can have, as I say, effects on power, on how high aircraft will fly due to some of the impacts of that. So it's a fascinating area. I know some of my colleagues, if they're listening, they'll have switched off at this point because they know I go on about space weather art, but it's something that's becoming more of an interest to aviation. Kind of following on from the volcanic ash. So when we had the unpronounceable Icelandic volcano that erupted, in fact, there's a good altitude on that with Jacob Young hosting that they've got somebody from Iceland that pronounces it beautifully on there. But that really was a shock to aviation, that the kind of size of impact that volcano had, and the knock-on effects of the ash. And I think what we've tried to do as an organisation, and the Met Office are doing now, they've got the space weather capability, is get ahead of that, let people understand what the impacts might be. We get twice daily forecasts from the Met Office of what's going on the sun. As Emma said, we're starting to come into solar maximum. There's been a number of active sunspots recently that have emitted some big flares. So it's raising that awareness and making sure that the industry is ready to manage any impact that we see from it.
And it's funny you should mention volcanoes, because we're going to start going to some of the questions that we've had sent in, and we've had a couple about volcanoes. So we've had one that says, although it's not weather related in the main, but it obviously does relate in a little way, the likes of a volcanic eruption, will the Met Office control this or call the shots on go or no go for grounding flights and things like that? So I'll take that one and just say no. The Met Office are very good, but that's not their job, that's our job. So they will tell us what's going on. And in fact, things have developed quite a little way, because there's a second question saying, what about the volcanic ash Iceland that happened in Europe in 2010? And I'm going to have a go, because I went to Iceland not long after, and they said it was Eyjafjallajökull. Something like that. So that wasn't too bad,
like
I think. So hopefully that's not too bad, and anybody who speaks Icelandic is now not going to hate me. But back in those days, we didn't know a huge amount about the way volcanic ash worked, and we tended to literally just ground everything. And initially we did stop everything, didn't we? But these days I think we're much more nuanced about it, aren't we? We get if a volcano goes off, we get some volcanic ash reports from the Met Office now, don't we, Emma, that tell us where things are going to be.
Yeah, we use a specific dispersion model to use the observations that we get from the Icelandic Met Service on the ash and what they observe, and we pop that into our model, and we get an output of ash concentration and how that is flowing in the atmosphere at different levels, and we share that with yourselves to help you with your decision making, and also, you know, airlines as well can use that information to support them.
Yeah, and Kevin, I'm right in thinking, Ada, that the rules changed, because in those days we hadn't much information and we literally just stopped everything because we thought this is a safety problem. Aircraft ingest things into their engines and then their engines might stop. There's a famous case of a British Airways flight years and years ago overflying Indonesia that lost all 4 of its engines, wasn't there? And that, you know, eventually became a huge glider and then managed to land, and there's books about it and all sorts. But these days we're a bit more sophisticated than that, and we're now allowing the airlines much more freedom about decision about where they fly and how they fly, and we just try to make sure that our sectors are controlled. Am I right in thinking that?
Yeah, that's right. And I'm old enough to be around when and doing a similar role when that a volcano that you beautifully pronounce. You think, being Welsh, I would cope with lots of those consonants together, wouldn't you? But I wouldn't have been brave enough to attempt that. But yes, and I think an important thing to kind of point out as well, I think, is that, you know, we're a navigation service provider, so it's not our airspace to close or open. We don't do that. That's down to the Civil Aviation Authority that would do that. What we would do is set, you know, what we think is a safe capacity of flights to fly through that airspace, and we would work, you know, even in the event when it was kind of stuff we'd not experienced before. We were working with the Met Office, who were providing us with these ash charts. We were working with the CAA and the regulator to look at what the impact was, and it was an evolving picture, because you know, we were having to work with, again, you know, things don't stop at the country borders, so we were having to work with the Irish really closely on how they were going to manage things like Dublin arrivals and overflights in Irish airspace, and also down into Europe as it dispersed. And, you know, so the Met Office are one of the volcanic ash advisory centres in the world that give volcanic ash forecasts, and we keep a really close eye on the Icelandic Met Office website that tracks, because they, you know, it's a massively seismically active part of the world. Keep an eye on things that are going on there, and, you know, also on for Eurocontrol, they monitor. You know, Etna is another one that's quite active, but they monitor, and if there's any kind of warnings, aviation warnings that get put out for volcanoes, then they track them as well. So we're much more aware of the impact that it could have, and also more prepared in terms of what we would need to do should we be faced with an event like that again.
Yeah, hopefully we don't have to deal with too many of those in my time here.
No.
Don't need to be doing all that. Okay, we've had another question in from someone at Nav Canada, actually. Does the jet stream impact your operations? If so, how? And how do you forecast it? Well, I can say very definitely yes. It does impact us quite definitely. Emma, tell us about how you forecast about the jet stream and what information you give us.
Yeah, we provide Kevin's team a 7-day forecast in terms of what the most efficient and effective flight path or routing it, let's say, between 2 major airports, one based in Europe, one based in North America, and we do that both eastbound and westbound, and we provide that to them daily so that they know what the most likely routing is going to be, and they can then put that into their own tools and systems and create certain tracks or paths that are most likely that aircraft will follow.
Yeah, so Kevin, tell us about the tracks.
Yeah, so this is not my area of expertise. In fact, Jacob Young, I said on a previous one, is the expert on this. But we have most of the airspace structure across Europe is fixed. So you go from point A to point B to point C, and that doesn't change on a day-by-day basis. But across the North Atlantic, the jet stream, which is this strong wind in the upper atmosphere that changes and determines a lot of what our weather's going to be. And we try and plot on a daily basis the routes across the North Atlantic. Now, the winds come across the Atlantic from America to the UK and to Europe. So coming eastbound, the aircraft like to get the most optimal jet stream winds they can, and they can be very strong. They can be 150 knots or more, and that's why, when you're flying from the US to Europe and the UK, your flight time, you've hardly had time to put your meal down and get a few hours sleep, and you're arriving. Whereas going the other way, you're going against the wind. So airlines like to avoid the strongest winds that they can going westbound. So those routes do change on a daily basis, and the impact of that is not just on the UK, because you imagine if the preferred route is up to the north, say over Iceland and then to Newfoundland and into the US that way, that takes a lot of European traffic through the UK, up through kind of the Lake District into Scottish airspace and out onto the ocean. Whereas if the preferred route is kind of more over Southern Ireland and out onto the Atlantic that way, that'll take some European traffic through France and then through over kind of London, high level over London, and then over Wales and out to the west. So that can have a massive impact on where we need to supply capacity in our network. And that's, again, the beauty of working so closely with the Met Office and having this data available, is that we can start to see kind of seven days out where this demand's going to be, and we kind of set up our capacity to deliver against that. And the other thing about the jet stream is on a really strong jet, if it's quite small in terms of its lateral extent, it can be quite bumpy. So if you're coming across the North Atlantic, it's a really strong jet, it can be quite turbulent, because if you're just on the edge of that where that core of the high winds are, it can be we can have a bit of turbulence there. So again, that's another thing that impacts the capacity of the North Atlantic.
Yeah, and for me as a controller, that makes a real difference as to literally how quick the planes are going to arrive, especially first thing in the morning. We have that rush over from America that all want to land first thing in the morning, and the general public, and rightly so and understandably so, don't particularly want noise over their house at 3:30 in the morning. So we try really hard to make sure that the plans are in place, that aircraft come in and land according to the local noise restrictions, and working with the airports all the time to minimise noise for the residents locally. And the aircraft are going to fly and be affected by these wind conditions, and we're trying to make sure that we optimise the routes that they can fly on, so they burn the least fuel, but that they arrive at the best time for them to then not have a delay and be able to come in and land, and not be causing any more environmental impact than they need to, because that's really important to us as well. So yeah, that's a big deal. And then of course everyone wants to go out the other way, and that will make a preferred bias on departure. So when you come to sort of the middle of the day and everyone wants to go back towards the Americas and that way, we're then looking at which routes are going to be most heavily laden for the day. And sometimes aircraft want to go straight out to the west, sometimes they want to go more to the southwest, sometimes they're going to go north, and we've then got to manage the flow of traffic in those sectors to allow as many aircraft through as we possibly can, but in a safe manner, and make sure that we've not got too many planes in the same place at the same time. So that's kind of a really important thing to us. Got another couple of quick questions to get through. So I've got one here saying it's a really interesting webinar. Thank you very much. We're glad you enjoyed it so far. You fly commercially out of Bristol. Do controllers have the ability to overlay their weather radar so they can see what and where you're likely to be requesting as a pilot? Sadly not, but actually with quite good reason. We've got the forecasting things that Emma gives us, which are great, and we do have a weather radar picture near us on the console, but we deliberately don't overlay that because we very much trust the pilots to ask for what they need when they need it, and only ask for what they need, and we accommodate that within our plans when we can. The danger is that if the weather radar isn't giving us quite the picture we're expecting, or we try to make you avoid something that we can see, and it then puts you into something worse that we might not have picked up on our weather radar, that could put you into a greater problem. So we don't run with that as things stand at the moment, but we've got lots of bits around us that can help us. So we do generally get a fairly good idea, and so sometimes as well we'll talk to pilots and say, oh, the previous colleague on this route said they needed to go right, let me know if that's going to be a problem, or if I give you this heading now, will you be able to fly it for the next 10 to 15 miles so that I know I can make a new separation with a different aircraft and manage the way that you're going to fly. So that's that bit. What else have we got? Why at London Heathrow is the flow rate during fog slow to increase when it's lifted significantly? And that's come to us from colleagues at British Airways. Well, Kev, let's talk a little bit about how long flow restrictions take when we put them on, how long they take to have an effect, and how in advance we need to think about those.
Yeah, okay. So flow measures, we can only apply these measures to flights originating in Europe. We can't apply a measure that applies to flights coming from the Far East or the US. It's really across a wide part of Europe. Now, clearly, we can only delay a flight when it's on the ground. We can't, once it's airborne, it's coming. We can't stop it at that point. So we have to apply the measure when it's on the ground. So thinking about, our position, our geographical position in Europe and the size of Europe, some of the flying times from some of the cities into London, for example, can be quite long. They can be 3 or 4 hours. So really, you need to try and catch the aircraft and catch the regulation at an appropriate time so you can capture as many flights as possible. The other problem, if you apply it too late, is that you've got a smaller pool of flights to manage, to manipulate. And what happens then is, rather than 100 flights having 2 minutes delay, you have 2 flights with 100 minutes delay, and we absolutely want to avoid that. So we have to apply it at the appropriate time. Equally, we don't want loads of aircraft holding in the skies unnecessarily. So getting the time of application is absolutely crucial, and we've done a lot of work with the Met Office on that. In terms of lifting the rate, again, we've got to factor into the plan that there are aircraft that are coming anyway, so they're extra on top of the rate, and also the confidence that once the fog lifts, it is going to disperse. So sometimes it lifts into low cloud and everything's great, the fog's gone, and then it starts to come back again. And we've all been in those situations in the past, and so we've got to be confident that the trend is that it's going to improve and stay that way. So we do react and manipulate the rates as quickly as we can. The other things that we do, which are kind of slightly technical elements, is that even though we've got a rate in place, we might call on some extra aircraft. So if we've got aircraft nearby that we know are ready to go, they've got the doors shut, they've got the people on, they're kind of on the taxiway ready to go, my team will phone the airfield up and say, right, bring that aircraft on so we can fill that gap. So we, as we said throughout this, safety is the absolute priority, but we hate applying regulations to flights. So we really try and optimize the network. Sometimes it's not obvious why we're doing what we're doing, but we really try and use some of these advanced techniques to get the best supply of aircraft into an airfield.
Absolutely. Couple of last quick questions. With the Met network relying on hundreds or even thousands of sensors providing accurate live information, do we also get feeds automatically from aircraft in flight? Any of you know? I know I get information from pilots, so I'll ask them and they'll tell me what's happening. But Emma, do you get information fed down?
Yeah, absolutely. Yeah. The information that aircraft provide us is invaluable because we don't get much vertical information of the atmosphere. Quite often for us to get that, we send out balloons into various locations across the UK with weather sensors on them, or we see it from above from satellites. But aircraft they have sensors on them that capture wind information, wind profile information and temperature information. You may see it sometimes when you're on an airplane that has a TV in front of the seat, and there'll be a section showing you speed, wind, temperature, and temperature and winds, and that's basically the similar sort of information that gets fed directly to the Met Office, and that goes into our forecast model in our supercomputer and helps with the forecast. So yeah, definitely.
Brilliant. And so last thing to just round up then, we've been asked, are there any particular good apps or websites that a normal person, because obviously we're not normal people at all, that a normal person could use, a non-aviation based person could use to see the weather, maybe perhaps better than, I better not mention brands, that certain other weather apps that people may have seen. Anything that either of you two would recommend from a weather perspective?
Well, I know what Emma's going to say, because she gets sacked if she said anything else, I'm sure. Go on, Emma, you say your bit.
Yeah, there's a Met Office app. It's brilliant. you can pick whatever location you would like in the UK. It gives you information not only about kind of pictures and stuff, but it gives you actually quantifiable information like humidity, wind direction, sunrise, sunset, UV levels. There's also radar, and there's also a tab for the weather warnings that are in place. So I would definitely recommend that. If you're an aviation end user and need aviation forecasts, for example, TAFs, or certain products like the volcanic ash advisories, then the Met Office also has network weather resilience. So if you search network weather resilience Met Office, it will be available on any search engine, and it's also compatible for desktop, tablet and mobile.
Perfect. I think that's a brilliant note to wrap up on. I'm afraid that's all the things we've got time for today. My huge thanks go to the lovely Emma and the lovely Kev, who've been absolutely brilliant today. Thank you to everyone who's been watching us. Hope you found it interesting and fun. I certainly have. It's my first go at it and I've really enjoyed it. So hopefully that's been good for you too. If anybody's got any feedback or any ideas for any future topics they would like to be talked about on Altitude, then please let us know. You can email into us at info@nats.co.uk, or you can tweet us at NATS if that's your thing. Keep an eye on the NATS social channels for details of the next show. Thanks very much for listening, and goodbye.